So to quickly define Henry's law before jumping into the details, we can say that a dissolved gas's concentration and pressure are directly proportional in a sealed vessel. So let's highlight some key terms. We're saying that the gas concentration and pressure are directly proportional in a sealed vessel. Now let's take this bottle of pop or a can of soda. Now when you open that bottle of pop for the first time, it's brand new. You open it up and you take a sip, it's going to be highly carbonated, and that's what we enjoy. Now let's say over time you leave that can open, or if you leave that bottle open, when you come back to your pop or soda, you're going to notice that your drink tastes flat. And by flat, we mean that it's less carbonated. Now why is it less carbonated? And that's the interesting question we're going to ask, and the answer to that is Henry's law. Remember, Henry's law says that if we increase the pressure, the gas concentration will increase. And gas concentration simply means that our solubility of the gas will increase. So if we have a high pressure means an increase in solubility of gas. We can increase the concentration of gas. So when we have this bottle of pop, we see this airspace over here, and this airspace exerts a pressure down onto that liquid. When we remove the cap, this exertion of pressure on the liquid is going to decrease because the carbon dioxide is able to escape through the bottle because it is exposed to the air. There's no longer the lid there. And if we expose that carbon dioxide right over here in this airspace, we're actually decreasing the pressure. Right now the pressure is higher because it's a sealed vessel and air can't escape it. When air escapes, the pressure over here decreases, and if the pressure decreases, our pop tastes less carbonated because the gas concentration or the solubility of that gas has decreased. I hope that makes sense, but I'll reiterate one more time. Essentially, what happens is that if our pressure decreases, our solubility of the gas is going to decrease. And if our pressure increases, the solubility of a gas is going to increase. So essentially, they are directly proportional to one another. If one will increase, the other will increase. If one decreases, the other will decrease. And that's Henry's law. And we can see this equation over here that defines Henry's law. We have P sub A equals K sub H times A. A represents the concentration of our gas in molarity. K sub H is simply a gas constant, and this gas constant will be different for different gases at different temperatures and within different solvents. And P sub A defines the gas pressure in the solution. So as long as we know this equation, we can solve for any of these values with simple algebra. Now let's take a look at this question. So it says the concentration of oxygen gas is 4.6 times 10 to the negative 4 at 1 atm. Now I want you guys to note that these are just hypothetical values. They may or may not be true in real life. So let's highlight as we go. The concentration of oxygen gas is 4.6 times 10 to the negative 4 at 1 atm. In lab, you increase the pressure to 4 atm. What is the new concentration of oxygen gas? Now the first word I want you guys to make note of is the word increase in pressure. Remember, Henry's law states that concentration and pressure are directly proportional to one another. If we increase the pressure, we increase the concentration of dissolved gas, okay? So that means that if we increase the pressure in this question, we will also be increasing our concentration of oxygen gas, which we start off with this value of 4.6 times 10 to the negative 4. Now this pressure, we start off at 1 atm, but we're ending off at 4 atm. This is very important because we're increasing the pressure by 4 times. And if pressure and concentration are directly proportional to one another, and if the pressure increases by 4 times, the concentration must also increase by 4 times. Now, there's a small error over here. I want you guys to make note that the concentration has units of molarity. Remember that in order to utilize Henry's law, this value over here must be in molarity. Now, if I rewrite the equation down here and I say P sub A equals KH times the concentration A. And I increase my pressure by 4 times. Well, P sub A and the concentration are directly proportional to one another. So if I increase one by 4 times, the other one also must increase by 4 times. So that means my original concentration was 4.6 times 10 to the negative 4. And I must multiply that by 4 to get my new concentration. And my new concentration is going to be 18.4 molarity. 18.4 times 10 to the negative 4 molarity. And that's our answer to this question. So what did we do? We knew that if we increase the pressure, our concentration is going to increase because it's directly proportional according to Henry's law. If the pressure increases by 4 times, the concentration must also increase by 4 times. So essentially all we have to do is multiply that 4.6 value by 4. So next up we have this application question. Now I'm going to read this question and then I want you guys to take a moment, pause the video, and think about this question. So if the volume of a vessel is increased, will the solubility of a gas increase or decrease? I'm going to highlight some key terms for you guys. So it's saying that the volume of the vessel is increased. Will the solubility of the gas decrease or increase? So take a moment, pause the video, think about the answer, and then I'll go over it. All right, so this is actually a great application question because we're involving this concept of volume. So when we started talking about Henry's law, we only talked about pressure and we talked about the solubility of a dissolved gas. But now we have this word volume coming in. So how do we know what happens? Well, we have to go back to our Boyle's law. Remember, in Boyle's law, it is stated that volume and pressure are inversely proportional to one another. So if the volume increases, the pressure decreases. And if the volume decreases, the pressure will increase. So they're opposites of one another. The question says that our vessel, the volume of the vessel increases. So if the volume of the vessel increases and volume and pressure are inversely proportional, that means that our pressure will decrease. Now, what do we know about Henry's law? Well, Henry's law, it states that the pressure is equal to some constant K times our concentration. Now, remember that our pressure and concentration are directly proportional to one another, and concentration can be used synonymous with solubility of a dissolved gas. Now, if we decrease the pressure, remember we're increasing the volume, so we decrease the pressure. If we decrease the pressure, that means that we must also decrease the concentration. If we decrease the concentration, that means that we decrease the solubility of the gas. So the answer to this question is that the solubility, would it increase or decrease? The solubility would decrease. Now this is actually a great application question. I'm going to go over it one more time. So if the volume of the vessel increases, we think about Boyle's law. Boyle's law says that if pressure it decreases, volume increases, and if volume decreases, pressure increases. So if the volume is increased, our pressure will decrease. And then we know in Henry's law that if our pressure is decreased, the concentration of dissolved gas would decrease. So the solubility of our gas will decrease.